Okay, now I'll share with you where this control plan comes. I'll go a little slowly from here. I'll share with you where the control plan goes. Okay, there is a define, measure, analyze, improve, and control. Okay, in the define, we have covered all these chapters, and in the measure phase, we have covered so many of these lessons. And in analyze phase, we have covered everything. In improve phase, control phase, and we are going to go through this control plan. All of you type CP in the chat box, which is control plan. Fantastic. All right. Now I will tell you, all of you type FMEA in the chat box. FMEA stands for failure modes and effects analysis. On a scale of 1 to 10, please share your knowledge on FMEA. 9 or 10 being it's decent knowledge, or 1 or 2 is just, you're a beginner. I don't know what is FMEA. We've not heard about that word and stuff like that. So we have a mixed response here. And if you want to know about FMEA, I've explained in depth in the earlier session. I will share with you the link of the videos where you can access that also. Okay, there is a mixed thing. Let me quickly explain to you what is FMEA. Okay, FMEA is failure modes and effects analysis. What is failure modes and effect analysis? It is a preventive tool, okay, which means that after the design has failed, you should not be reworking on the design. You have to make sure that you make a design in such a way that failure doesn't happen because of design specification. Similarly, when the design specification from the design, when you are manufacturing the product, after the product fails after manufacturing, you should not be doing a problem-solving methodology. This is a proactive methodology, okay, not a reactive methodology. Problem-solving is a reactive methodology, and FMEA is a proactive methodology, which means that we will see what is possible for it to fail. When you go for a trekking, you know what is the problem that you face during trekking, right? Similarly, you will equip yourself so that you won't, of course, and when you go on a ship or river rafting, okay, you will put all the, you will forecast the weather and stuff like that, and accordingly go. Instead of, after you fall into the water, send the lifeboats. That is problem solving. Okay. And after you fall down, put a bandage. That is problem solving. Okay. So if this is clear, type SC, super clear, in the chat box. This is just the few minutes that I can share, but I have shared in detail in the earlier videos. So you can see my earlier videos, because FMEA is not a subject today. I'm just giving you the overview of this FMEA. All right. Now, the purpose, as I said, is to identify the potential failures in the process and their causes. So in the initial use, we introduce in the define phase and the measure phase. Okay. And we have listed potential points and ranked them based on severity, occurrence, and detection. All of you type SOD in the chat box. These are, people who are new here, don't get overwhelmed. Just stay with the session till the end. This is only another half an hour that we are going to interact, and take good notes. Okay. And eventually, when you attend all the sessions, everything you can catch up with. Okay. And there is something called as RPN. You can type RPN is equal to S into O into D, severity, occurrence, and detection. That much in this session, that's more than enough. Okay. RPN is equal to severity into occurrence into detection. That much that is more than enough in this session. All right. Now, why should we revisit this thing? For me, because after you have done the improvement, you have to assess the changes made during the improve phase, and we have to recalculate, because after the improvements have been done, now what is the risk? Okay, now what is the risk? So if the product of the severity, occurrence, and detection comes as a lower number, that means there is a significant improvement. Okay, and we are revisiting FMEA because we want to identify any new potential issues that might come and plan for any future enhancements and reinforce Six Sigma role on an ongoing initiative. Okay, I'm not going to explain these statements in detail because these are all self-explanatory, but all you need to understand is it is important to evaluate improvements and do continuous improvement. If this slide is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear before I jump on to the next slide. Okay, now let me quickly explain you what are the initial steps to revisit this FMEA. The reviews are taken, document all the recommended actions, verify improvements that they address the root causes effectively, and recalculate old RPN and new RPN, and highlight the improvements in the scores. Okay, and then update the FMEA. That's very, very important, because now that your risk number has come down, some other number might be in the top. So it is important to see one by one and continuously de-risk yourself. All right. Okay. So benefits, if you see, is demonstrate the tangible improvements. Okay. Because when the RPN number has come down, it means that you have demonstrated that the improvement is permanent. Okay. And it is a proactive risk assessment, because after you have done the improvement, now that you know, you put control plans in place. Now I'm introducing control plan. Now you put control plan in place so that you don't slide back, creating a risk. Okay. So if this is clear, type CC, crystal clear, in the chat box. So, and hence the need for the control plan. Control plan, now that you have done FMEA, the risk number has come down after improvement. Now the improvement should not slip back. The greatest challenge that organizations face today is after the improvements are made, after a few weeks, few months, or few years, they gradually skip back to old ways. Okay, thereby posing risk. If you can relate to this, type I can relate, ICR, in the chat box if you can relate to this. So what is control plan? The purpose of control plan is to help the process owner, to help the business team track and respond to key performance indicators. What is key performance indicators? KPIs, what matters to the business, right? So that the process sustains the benefit that it has delivered. Now let me go into the depth of this. What is a control plan? Okay, so far, if you found it interesting, useful, fantastic, awesome, put it in the chat box. Let me also get some inspiration and proceed with the session today, understanding the control plan. Definition of control plan. A control plan is a structured documentation. It ensures process stability and quality maintenance over a period of time. The purpose of the control plan is, all of you type CTQ in the chat box. If you don't know these terminologies, don't worry, because you've joined somewhere in the middle, and these sessions are ongoing sessions. You continue for week on week, you will get everything clear. Okay, and when you become a part of the upcoming session, I will also give you a certification, how to get your certification. Okay, that's why it's important for you to register for the upcoming session, because the purpose of here is not to sell you a certification product. Okay, the purpose of here is to inspire you to learn. If you feel that you need to take the learning to the next level, till the level that you get qualified as an internationally recognized certification, then I have a separate session for that. I don't want to mix up that here. Now the purpose is to document what is critical to quality, so that those critical to quality parameters do not slip back. If that slip backs, then your product will have defects or rework or will get rejected, right? So to document this critical to quality parameters and to define how these parameters will be monitored and controlled. Very, very important. All of you type M and C, monitored and controlled. Both are important. You have to monitor that, you have to control that. Very, very important. Okay, to prevent the process deviations after post improvement. And the key features are, it has measurement methods, control methods, and reaction plan. CM, RP. If you want to take notes, if you want to remember, CM, and RP. What is Measurement methods, control methods, and reaction plans. Those are the key features of this. Great, fantastic. I like everybody typing. That's an active participation. Very good. It focuses on sustaining the gains. Very, very important, right? Sustaining the gains is very important. Excellent. So crucial for ensuring long-term success with Lean Six Sigma projects. Okay, now the control plan, let's get into the depth of it. It provides a reference among characteristic specification and instructions. When I explain this control plan, all this, whatever I'm explaining, will become very easy. I'll also give you a template, okay, for you to do this. It covers all the process area, operating procedures, preventive maintenance, gauge control. All this preventive maintenance, operating procedures, gauge control, which is measurement system analysis, MSA. You can write down this word in your notebook, MSA, measurement system analysis. Okay, so control plan will address all these areas, okay, so that you might slip back to old ways because your procedures are not okay, because your maintenance is not well established, how to maintain the machine, and your gauges, what you're using for measurement. So control plan will encompass all these things. It's a live document. All of you type live in the chat box. It's a live document, okay, which is kept current, available, and understood, okay. So control plans need to be in writing, sufficient and effective, usable, adopted by many owners, okay. Now the question. How many of you are ready for the question answer? Type ready in the chat box. I'll impregnate this presentations with some questions. Okay, thank you very much. What is the primary purpose of control plan in Lean Six Sigma? To improve process efficiency, to document and sustain process improvements, to eliminate all the defects in the process, and to identify root causes of the process. Everybody knows the answer? Okay. It is not to identify the root causes, okay? It is to document and sustain process improvements. All right. So congratulations to all those who typed B. That's the right answer. So why should you learn about control plans? Why should you learn about control plans? Let's quickly see why we should learn about control plans. The control plans, I call it as an institutional memory. Okay, we call about knowledge management these days, because that is where when new people comes, they take out this control plan and say this is how you have to sustain. Okay, it focuses on operational excellence. It's a first step in process control. This is a master document, okay, where all the details are given. So there is something called as a reaction plan also as a part of this control plan, where when something goes wrong, what to do is also listed there. So it becomes a basis of training, and it becomes an auditing tool also, because based on this control plan, you can verify and see whether people are following the procedures or not. Okay, and this is also linked to ISO. Okay. Okay, if this slide is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear. Good. Thank you very much. Now, the components of control plan. This is going to be very interesting. Now, you can control the process by various tools. Some of them I'll give it here. There is something called as change or revision control procedure that you can write. You can redesign the process. You can update in the FMEA. You can do mistake proofing. You can use the 5S methodology, which I've explained in the earlier video, and visual workplace. We are going to go into the detail of the visual workplace. Preventive maintenance, training plan for both current and future activities, standard operating procedures, standardized work, reaction plans, long-term MSA plan, statistical process control. And you can use many of these tools from the toolbox. If this is interesting, super interesting, type SI in the chat box. These are all different components. I'm excited when I prepared this actually. All right, great. Super, super, super interesting. Very good. So, now, The elements of the control plan is this. There is a process name and description. I'll give you a template and I'll explain you the template, okay? There is a process owner. The critical to quality parameters are written there. So process name and description is written, process owner is written, the critical to quality parameters are written because all the specification, what needs to be maintained is written. What are the measurement methods is given there. The control methods are given here. How do you control that parameter in the machine or process? Okay. And what do you do if something goes out of this? This is called a reaction plan. Okay. And how frequently do you monitor things and how do you document and record that? Okay. Simple, all of you write SIMPLE, simple in the chat box because this is not complicated. This is simple. It calls for discipline. That's all. This calls for discipline. Now the question and answer. Okay. Now the quick question and answer is, which of the following is not a component of control plan? Now that I've explained the components of control plan, what is not? Process owner, reaction plan, profit margin, CTQ parameters. Simple answer, right? Of course, profit margin is not a part of the control plan. So unless people know what is components of control plan, they cannot answer this question, right? Okay, how do you develop the control plan? Let's see. The steps are, we said, okay, which are the parameters which is critical to quality? You identify them. And then what is the method by which you control them? And what is the way in which you monitor them? And who should do that? Assign the responsibilities. And if it goes wrong, what are the reaction plans? And make sure that you train the staff based on that and test that control plan as a pilot test. Okay. So if this is simple on a scale of 1 to 10, please give me a 9 or 10 if it is simple. Okay. I'm going a little faster because these are all self-explanatory, but I'm not reading out word by word line. I hate reading word by word. Okay. Right. Awesome. Now the question is, what is a step in developing a control plan? Train the staff on the plan, identify CTQ. First step, what should you do? Define the reaction, which is the first step in developing a control plan. I've already shared that, right? Okay, identify what parameters to be controlled. That's the first step. All right, fantastic. Okay, now the control plan has got different components. I'm going to give you a template of this, and I'm not going to explain each and every component of this. Okay, the first is called as an administrative part of this template. Administrative part of this template has got process name, customer, location, area, prepared by, approved by, and things like that. Okay, so these are the, I'm not going to explain all this. Okay, and you know, process name, customer, location, area, prepared by, all that has to be written here. This is the administrative side. Okay, another component is called as substantive. Okay, substantive. What is substantive? It is consists of two components, and this is something that you will not see in many books. Okay, now if you see, this sheet has got two components. One is subprocess steps, CTQ, specification, characteristic, etc., etc. Now, I'm not going to go into the depth of this because if I go into the depth of this, you'll find it boring and you'll leave the session. Okay, but I'll give you this presentation. Don't worry. You can see this recording also. That's also I'll give you. But then focus on what I'm going to explain each of these components. Just know that this consists of two components. One is, if I take a closer look at the first half, I have put a number 1, 2, 3 here. One is you list the process step by step. If you're making coffee, what are the processes in making the coffee? List the steps one by one. And then under the steps, what are the sub steps that are there? You list that. Then in that sub steps, what are the critical to quality characteristic you are going to adjust? For example, in coffee making, if you see boil water and boil milk and add sugar and stuff like that. And when you are mixing this, what are the sub steps in that, and how do you control? What are the parameters you will give for, okay, what temperature you should keep, when you should add sugar, what time you should add sugar, how much quantity of add sugar? These are all critical to qualities. Okay, then how do you inspect that? What is the inspection criteria and stuff like that? So this sheet, if this is clear, give me a 9 or 10 if it is clear. This is not a big rocket science. This is simple. So just wanted to ensure that it'll be boring if I start explaining each and every stuff of this. I'll give you this template for you for ready reference. Okay, so it should not be a problem. Let me explain the second component of it. Okay, the second half of it. This is the second half of it. What is more important is the sample size, frequency, who measures it, who records it, corrective action, and this thing. Okay, if you see the second component here, I have clearly written the common parameters for control, sample size, frequency, and personal utilization, and what to do if there is a non-compliance. That's called reaction plan, right? And show the linkages to the FMEA preventive maintenance plan. This is so that they can refer those documents and make sure that they control the process. Okay, so far, if you found it interesting, useful, valuable, fantastic, awesome, put it in the chat box. Give me some inspiration. I'll move on to the next slide. Notes on control plan. What is a note? Quick note. Control plans are documents that are used to keep up the process running in control. Okay. It empowers the local control of the process by providing timely information. It gives instruction on what to do if the process goes out of control. This is very important. This is called reaction plan. Okay. It is like a guidebook for the process owner using a training of new processes. And so it will not add any, whatever in the control plan you follow it, it will not add any. Don't add any unnecessary work. Otherwise, people will not follow the control plan. Whatever is absolutely necessary, please put it. The more work in the control plan, the less likely it is to be followed. Okay. So it requires simplicity. Okay. Control plan must be simple. Okay. For it to be effective. Otherwise, people, how many of you can relate to this? Because you made a control plan, people don't follow it. Okay. They follow their own old ways. If you can relate to it, type ICR, I can relate in the chat box. That is because the control plan is done only for the sake of ISO audits. Okay. If you can relate to this, you can type ICR. It is not done to truly maintain the control, okay, to help people. It is done because the auditor, otherwise he'll strip you of the certificate. All right. Good. Now, I'm going to share with you something very, very important. Okay. Now, there are different levels of controls. Okay. There are different levels of control. I normally say this is passive control, active control, assertive control, aggressive control, advanced control, and ultimate control. Okay. Passive control, active control, assertive control, aggressive control, advanced control, and ultimate control. Now, what does it mean? Ultimate control is called poke-yoke. Okay, if people who know poke-yoke or foolproofing, you can type FP or poke-yoke in the chat box. That is ultimate control. Okay, there is no chance of error. Passive control is just verbal instructions. Okay, passive control is just verbal instructions. You say wear a seat belt, people are not going to wear. It is less effective. Whereas active control is to write it and put it. Assertive control is some light beeping. And no, screen is not stuck. I'm just wanted to explaining. Okay, and no, verbal instructions, can you see now? I've not moved, okay? I'm just explaining, okay? And finally, the engine won't start if you don't wear the seat belt. That is the ultimate control. So verbal instructions, standard procedure, okay? Buzzer light, yeah, correct. So I just wanted to explain to you this level of controls. But if you're in the lower level of control in the maturity continuum, you need to review quite often. That's not effective, right? Okay, let me explain to you this in the slide. Okay, people are thinking slide is stuck. No. Verbal instructions, standard operating procedures, training and evaluation, statistical process control, poke-yoke foolproofing systems, automation, okay, and process redesign and other things. The point that I'm trying to explain is if it is only verbal thing, your effectiveness is very less. Whereas if you go for process redesign and stuff like that, it is most effective. That sort of control is more effective. Whereas the effort to take implement, okay, implement is, verbal instruction is, you will have a lot of effort to implement this. If it is verbal, you should keep on telling again and again. But once you redesign the process, you need not have to worry about it. That's why I said effort to implement is least. Okay, so employ control method that ensures greatest control, okay, with least amount of ongoing effort from the process. How many of you agree with me? Type agree in the chat box. If you super agree with me, type super agree in the chat box. All right, fantastic. Thank you very much for your response. Now, quickly tell you the benefits of this. The benefits of control plan is sustains improvement from Lean Six Sigma projects. It helps in process stability and predictability of the process. Process is more predictable because people follow these control measures, then sustenance is more, then you can predict. It reduces unwanted waste and variations because you don't know what to do if it is not there, right? Then improves customer satisfaction, we know that. And application, manufacturing, healthcare, service industries, you can think of anything, any industry where these control plans are applicable. The question is, what is the role of reaction plan in a control plan? To train the staff on process monitoring, to specify tools for measurements, to outline actions for addressing deviations, to document customer satisfaction feedback. Let's see. All right, C is the right answer, to outline actions for addressing deviations.